You feel good?
Yeah?
All right.
Let's do this.
Hello, friends. Hello. Yay! We don't believe for a second that anyone here is a real developer because it's 9 in the morning. Real developers don't get up until at least 10:30. But we got up for you. How are you, Alex?
I'm good. It's good to see you all here. I'm excited about this talk.
Yep. So I'm Scott Hanselman, and this is Alex Ellis, and we are wearing OpenFaas T-shirts. And if you're nice to us, we may throw one into the audience, because I know that developers go nuts when you throw things into the audience. We will not be throwing Raspberry Pis into the audience as much as we want to, because they cut your face really badly. We're not going to do that again.
No.
All right. So here's our agenda for today. Why would you do this? That is a very good question. This is a totally dumb thing to do, but we did it anyway. Why? We've got the Raspberry Pi cluster here. And I would like to point out one thing. You don't really know what your male privilege is until you go through customs with a gun case with a Raspberry Pi cluster, and no one says a word. So I'm very much feeling my privilege right now because I brought in all kinds of suspicious-looking devices and things, blinking lights, and I was screaming, "It's a Raspberry Pi cluster using Kubernetes and OpenFaas," and they were like, "We have no idea what any of that means. Just go ahead." So, and then also, what counts as a cloud? Is this a cloud?
Yeah. So what counts as cloud? We're going to look at some of the top community clusters that have been sent in, the practicalities of running software on ARM, Raspberry Pi's ARM board, .NET Core, and why .NET Core is the right choice for ARM. And then we're going to get an introduction into serverless and Kubernetes, which is actually quite a complex topic, but we're going to try and tackle that for you today and give you some resources to get you moving on with that. And we've got some really cool demos too. There is a lot in this talk. We're doing our very best. This is our first time giving this talk and our first time working together, so please do bear with us. It is arguable that you could have Alex talk for 2 hours just on OpenFaas, 2 hours just on Kubernetes. I could go for an hour and a half on ARM and .NET Core, but we're going to try to shove it all into 60 minutes. That's right.
Crossing fingers. It's lower your expectations now, I think is really what we're trying to say. All right? So why would you do this? Well, it's the freaking cloud in your house. It's cloud. It's a little tiny cloud. I mean, when you think about the cloud, you think about computers that are in some warehouse somewhere that you can't visit.
Right.
But this is a real cloud. You can visit it. You can pull cables out of it.
Yeah.
You can also, be your own boss. Your root. You make the rules. It is hardcore local host root stuff.
It is.
And you made a really interesting point about Unix heritage that I thought was really good.
Yeah, so we were talking last night as we were trying to get this cluster working in Scott's hotel room, and I said, did you know when you add a user, it asks for a room number? Like, why would it do that?
So I went into add user here on my Ubuntu machine.
Sudo
make me a sandwich, and I can go in here and say, cool, password, full name, room number.
Yeah. So this is the thing. Why is it asking for a room number? Well, Unix originally was designed to be run in educational institutions, right? In universities, where you'd have a room number. So when I'm at home, add to user on my Raspberry Pi, I'm like, well, it's in my bedroom, it's in the kitchen, It doesn't really make sense, but what it does show is that we've come from this very rich heritage where one of these computers would have cost thousands of dollars, would have filled a room, and you could only use it if you're at a university somewhere. Now you have that in your house, in your hand, and we have what? 6 of them for, what did this cost you, like $300?
I think I put $300 into it total,
right.
And that counts all the custom cables, the power supply, the router. We'll talk about all of that stuff, but there's not more than $300 worth of equipment there. And you don't need to make one that's 6. It could be 3, It could be 4.
Yeah, so the great thing is, you get to own that. You can run whatever you like on there. And we've got so much freedom now compared to sort of 30, 40 years ago. It's a completely different landscape. So you've got direct access to the hardware. You can unplug cables if you want. You can add new ones on if you need more capacity.
All right, so we're going to back up and think about what does the cloud look like. And there's been a lot of great talks at NDC about learning, about how people learn. And I have found it difficult to explain to people what the cloud is. Older people will say, well, that's just what hipsters call hosting. I have a cloud. I go and I can visit my local hosting where I visit my server, Yeah. And the way I describe the cloud is that it is elastic, it is programmatic, and you can't typically visit your cloud's hard drive. When you put your machine in a host, you can drive down there, they can let you into the NOC, and you can say, that's the spinning Rust that holds my application. But with the cloud, you put 1 byte into the cloud, and suddenly it's in 6 places, right? It's in 6 different regions. But this is really like a little portable personal cloud. When you teach people the cloud, often we say, look, it's the cloud. And then we teach them obscure command line things so that they might learn Kubernetes. And I find that hard to visualize.
Right.
It's very hard to visualize. See the cloud?
It's right here.
Right. And there's lots of different clouds.
Right. So this picture is your, I imagine would be my AWS or my Azure, where I'm running my code at work. You don't really get to ever see this, right? You just imagine it looks a bit like that.
Right. This is the only time you see this is at the end of action movies. This is the
Yeah.
last scene.
Die Hard. But actually, there have been clouds for much longer than that. This is IBM mainframe, and this is what I was talking about sort of 30, 40 years ago. We had these huge computers that were shared out, and we would just have a dumb terminal, and we'd connect into it, and we'd get access to this huge computer resource. And we're going to talk a little bit about how serverless is a bit like going back to the mainframe days. We have this elastic capacity, and you can sort of tap into it. Mm-hmm. But this is a cloud as well, Scott. This
it absolutely is.
A bunch of Raspberry Pis arranged in a circle, and if you sit in the middle, just like in the Matrix, and you get shot, it will freeze in time, and you get a 3D picture. Now, it's very different from that first cloud I showed you, but it is actually a cloud. And we want to say that private cloud is what we're going to talk about today.
Mm-hmm.
Right?
This is your own personal cloud. Now, there's lots of different private clouds that you hear the names of. We talk about the Azure cloud, the Google cloud. I understand that there's a bookstore with a successful cloud. But there's also private clouds, right? Kubernetes is a kind of private cloud. OpenStack is a private cloud.
Yeah, and so many of you have used things like VMware vSphere, maybe at work in the enterprise. You go to it, you say, I want a new virtual machine. You decide the operating system. You have to do everything yourself. But it provides a layer of abstraction for you across a bunch of servers, a cluster. Mm-hmm. There are higher level things like Cloud Foundry and Kubernetes that work just at the application level. There's a lot of options here, and these are all really how you can create your own private cloud, but none of these run on ARM on the Raspberry Pi, other than Kubernetes, and that's what we're going to focus on today.
Mm-hmm. And when you think about the cloud, you have to ask yourself, how cloudy do you want to go? Do you want something that is entirely managed by you on premises, everything from the network all the way up to the applications? That is the kit car. We all have that parent that's trying to rebuild a car in the garage. That really has nothing to do with Uber, which is the other side here, software as a service, where I want to go from point A to point B, and I don't really care if I built the car from scratch.
Right.
Arguably, this is the kit car version of the private cloud that you've done here.
Yeah. So we are right over here on the left-hand side, I would say. And so we're managing the application, the data, the runtime, the virtualization, the servers, the storage, the whole works. Mm-hmm. When you do this, you're in charge of everything. Now, as you move across to infrastructure as a service, you've got something more like VMware vSphere. You move further, platform as a service is what Kubernetes is. Everything is handled by someone else, and you're just deciding what applications to run and how your data is defined. Software as a service is more similar to serverless. If anybody's used Lambda or OpenFaas, you create a JavaScript file or a .NET file, throw it over a wall, and forget about it. And that's all you have to do. Right?
Yeah, and I like to use all kinds of analogies around cars, whether it be build your car, lease your car, rent your car, Uber, or whether it be getting your own house and building your own house and building it from scratch and having to paint it, or platform as a service or software as a service like your hotel, like the hotel that we're staying in, that I completely thrashed because platform as a service, right? I'm going to come back and they will have reset the room. I don't know, it's magical. Kubernetes somehow will reset the hotel.
That's right.
It makes me feel good.
So
people are feeling awkward because they think I really did thrash the hotel. I totally did because I'm a rock star. So this is a way better way to visualize the cloud. That's one of your first clouds, isn't it?
Yeah, this is one of my first clouds. We have just these copper standoff screws. I always get asked about this. You can buy them on eBay, and they're a great way of building a cluster very cheaply and just stack up like that.
Mm-hmm. And on the left there is just me saying get nodes with kube control, and you can see I've got Hansel boss and Hansel workers 1 through 5, and that is Hansel boss and workers 1 through 5 that we'll talk about in a little bit.
Yeah, that's right. So I was going to talk a bit about my first cluster, because some of you, how many people already built one? Right? So
Pretty good. 4 or 5
you're in
people.
the right place, because we're going to tell you how to do this from the beginning to the end. So I first thought, well, I want to build a cluster. I didn't really know why. I just thought it was really cool. And at the same time, I was at Pi Wars, and I met a publisher from Linux User magazine, and he said, have you thought about writing for a magazine? I'd love you to write for the magazine. And I said, well, my writing wouldn't be up to scratch. There's no way I could do that. And I said, well, what about this blog I've written? And he said, yeah, that would be great. And so I ended up getting this blog published, How to Build a Raspberry Pi Cluster. But things were much harder. You're in a much better position than I was. And this was only 2016. I had to build Docker from source, which meant spending all night run your batch job, wait till the morning. If you missed something or you missed a patch, you've got to do it again. It was a real pain.
Which is funny because it harkens back to the time when you had time-sharing machines that were the size of a refrigerator and you would wait all night for the...
Exactly. And you could kill the SD cards because you're writing to them so much. They've only got a very limited life cycle. And so that was another real pain. These days, you can install Docker and Kubernetes with apt-get, like a single command, and you've got it. So you're in a much better position. And actually, just to show how quickly this is changing, Docker has its own Kubernetes called Swarm. And I was actually using the previous version, and they sunsetted that and built a brand new one. And what are we, just 2 years on?
Yep, and you've taken from building Docker from source, and now you can go to Alex's blog and basically with a gist, following instructions, build your own with off-the-shelf parts in a day.
Yeah.
So thank you for doing that work for us.
Thanks.
Appreciate it. So I thought that this was amazing. I built one. He and I did a podcast, and once we did this podcast, the word starts to get out, right? We're certainly not the first people to do this kind of stuff or think Raspberry Pis should be used and abused. But once we started talking about it publicly and saying how exciting and how fun it is and what a great learning tool, people started tweeting pictures of their clouds, their own private clouds.
Yeah.
And I would please encourage you to check out that podcast. So these are some of the community clouds, and what's even greater is that not only are people building them, but they're submitting talks to conferences. So hopefully you'll give a talk about something cool that you made on your cloud.
Yeah, yeah. So we have John Calloway there, and you see I think he's got a Windows laptop. Some people are using Linux laptops and Macs, and so we're bringing the whole developer community around the Raspberry Pi. And that's a really great, rich experience because I've seen how you've come at this from a PowerShell perspective. Mm-hmm. I've been doing it through my Mac, and there's all of this melting of ideas together. So we've got a cluster here from Gregory, and then one that's a bit bigger there from John. They're both running OpenFaas on it because before OpenFaas, it was well, I want to build a cluster. People would build it, post a picture, and then they'd just turn it off and gather dust. They didn't really know what to do with it. And it's kind of cool how people have latched on and found, well, actually, I can just run my functions on it. I can put webhooks coming in through my firewall. I can send messages to Slack. I can start to work with events. And this is one that came in from Baptiste. Again, he's got a Surface Book a bit like yours.
Mm-hmm. Yep, I'm doing mine on a Surface Book too. He's got his Mac right here. The only thing we have in common is USB-C, which sucks. But what the great thing is that when you're doing Hello World, of course, you don't want to go and just spend $300, buy this, and say, well, I don't always do Hello World, but when I do Dockerized, containerized, distributed Hello World in the cloud on ARM in .NET. I want to do something useful with it.
Yeah, yeah.
And OpenFaas makes that possible. So we're going to talk about those layers and where OpenFaas sits on the top. And I turn mine on all the time. Yours are on 24 hours a day.
Yeah, I just leave this running. Sometimes I get so sick of having so many IP addresses used up on my network, I just turn everything off. I can never find anything. So you just need the Raspberry Pis and a switch, that's it. It doesn't have to be expensive, but just like we see here, people make their own sort of twists on it. And so we've got a hub, I think, at the top of that cluster. Scott's got his USB-powered one here, which is really cool. And so you've got a lot of freedom. You can actually do something like this. This is Resin. My friends at Resin put this together. That was 288. It's called the Beast. It's the third version of it. But actually, I think they ended up with 360, and it takes 5 kilowatts of energy to run. Sounds like a lot, right? But imagine that in Intel servers, in your Xeon processors. It would be many times more. Now,
lots of different ways to do it. Maker community has made their own cases by cutting them out of acrylic. People have made them with Lego. I use standoffs, and I've got a little power thing at the bottom. We'll talk about the parts that we each recommend, but the great thing is that there's no one way. You can literally use standoffs and whatever USB power supplies you have lying around, or you can be creative and build something classy like this one that Alex Miller did.
Exactly. And what I really love about this is the Raspberry Pi community is full of makers, people that are really comfortable just making something brand new. I used pieces of copper to stand them off because I don't have those skills. I can do the software, and I love it when you see something like this come together, and it's so neat. So people love building their own cloud. I hope you will love building yours too. I'm just going to try and help you along the way here.
So we're not people with big egos, but it's possible that this massive uptick in the discussion of the .NET Framework, Raspberry Pi, and Docker was entirely because Alex and I were tweeting about this. I'm just saying. It could also be the holiday slump and that people came out of Christmas, but we have decided that that's just our excitement about Raspberry Pi that has caused us to literally move Google Trends. You can make your own conclusions. I don't think you would probably go that far, but
no.
It was exciting to see that there's people chattering about this. Lots of discussion.
I mean, when you look at it, the 3 topics that we picked for this talk, .NET, Docker, and what's the other one? Raspberry Pi. Just together, the sum much more than a sum of the parts. I mean, how much interest is behind this? It's just incredible.
And it really is a testament to open source. As someone who's coming from the .NET world and saying, I'm running .NET Core, which is open source, and I'm running it on ARM and on Kubernetes, and there wasn't anything tricky or unusual that I had to necessarily do to enter that world.
And a couple of, maybe even a couple of years ago, your only option for Linux and .NET was probably Mono, right? And if you've used Mono, you can only get so far, and it was kind of slow on the Raspberry Pi. .NET Core is much quicker. And so if you love .NET, and that's what you do at work and what you do at home, you can now start doing it in your cluster and in your own time, and it just opens up more doors for you.
Right. And with OpenFaas, which is non-denominational, on this Raspberry Pi cluster, I've got Go, I've got Python, I've got Node, and I've got .NET all sitting together, and they are all friends.
Yeah, exactly. So we're talking about .NET, we're talking about clusters, we're also talking about Kubernetes. Now, Kubernetes is what's called an orchestrator, and if you've not heard of orchestration and Kubernetes, we're going to explain a little bit about that. But first of all, who would actually need one? Why would you need an orchestrator?
Right, because I've been doing a lot of Docker, and Docker's great. It's a formalized, containerized, official way to run stuff. And I really like Docker because I've been able to take applications that I wrote a year or a year and a half ago and rehydrate them.
Yeah.
Almost like dehydrating food and then just bringing them back. You just add water. One great example, if I may, was...
Are we doing fancy pants?
I'll do fancy pants. So, true story. I did a talk with Glenn Condren a year ago with a beta version of ASP.NET, and we called it Fancy Pants. And we just watched to see if people actually watch our training video that they would pull down Fancy Pants and go and do that. So this is old. This is old software now. It is a couple years old, and I can say Docker. I can't type because everyone's looking, so everyone turn away. And I think we put it on 80, and it was Glenn C. Fancy Pants. And I can just go and say, run that, and it comes down, and it's run, and then I can bring it up in my browser, and I think to myself, well, I don't need any orchestrators because I just brought back a really old application like that. I didn't say, hey, here's a virtual machine, go and use this. I didn't say, here's a 32 gig virtual machine on a stick to run my Hello World app. I just said it in one line. So I know I can reliably run that on your laptop or my laptop. What do I need an orchestrator for?
Right. So Scott's right. He was able to package up an application, and was that on Linux?
That was Linux Alpine.
Would have been Linux,
I don't really worry about it.
So Scott used Linux, and as you can see from this diagram, Docker, once you've built your code, you can ship it to your server, run it wherever you want, Windows or Linux. It works exactly the same. You can run it on the cloud, on your physical server, like this one, or on a VM. But there's a bit more to it when you start to run it in production. So a little bit more about Docker and the pros and cons. So we were talking about virtual machines just there. When you ship your application, the old way of doing things was you would have your application, maybe it was what, 100 meg?
Yep.
You've got your libraries, which is .NET, and then you always had to ship the whole OS with it, or you had to build out a virtual machine with Windows 2012, with Linux, every single time. With Docker, what you do is you have one operating system, one place to do your Windows updates or your apt-get upgrades, and you just ship your app and its libraries. And you can actually have, unlike with the VM, if you want two pieces of software there, .NET 2 and, if you really have to, .NET 2 and .NET 4.7 together would be really hard. They might interfere with each other, but with Docker, you can put whatever you want. You could have 1, 2, 3, 4, 5 if you liked, right? And that is all that you run. That's all that you ship. So we're no longer talking about managing the whole operating system. It's becoming much leaner.
Right, and what's so powerful about that, if you think about it from a historical context perspective, is that even as recent as 10 years ago, I would go and work with large banks that would tell me that they were remoting into production because, well, we've got Web 1, Web 2, Web 8. Web 6 is acting weird. We think there might be a DLL with the wrong version on it that snuck into production. Like, some of you are nodding because you know you're doing this at work, right? If you're SSHing into production because you're not really sure the configuration is right, those are classic problems. So then we try to solve those. We over-solve them by saying, well, we'll run everything in a virtual machine, which just made our problems times n.
So can you fetch that DLL from production? Because I need to run it through Reflector to see if my change is there.
Right.
Docker, that's no longer the case. You can look at the image. What you have on your dev machine is the same as production. Okay?
Additionally, it's worth pointing out that the Docker is code where the deployment can break, like the code didn't compile.
Right.
But I've worked at companies where the deployment was a Word document. Word documents don't tend to break the build. Docker allows us to automate a lot of that.
Yeah, so what I was talking about with the different versions of .NET, for instance, is that you've got like a sandbox, right? And it's isolated, so you can have whatever you want in there and it won't affect any of your other applications. We're talking about how we can actually densely pack applications. Scott was telling me when he used to work in the industry, if a server CPU got to 40% and held there, they'd ring a guy up and they'd bring another server on, maybe get it shipped.
Yeah. People would say, this machine's running too hot, CPU's at 50%. We don't have enough headroom because it might become popular tomorrow.
Right, but with Docker, we've taken this other approach. Like we've got our AWS account, we've got this huge bill coming every month. We want to densely pack in as much as we can, and with Docker, you can just keep packing it until you feel comfortable that you've kind of hit your limit, right? It's immutable. That Docker image will not be different. It cannot change. So if you restart the application, you're exactly where you were. And we're talking about a next-gen workflow. It's no longer, here's the checklist for production. This is how you deploy the application. This is how you build it. You have code. The Docker file is like code. And it says, look, do this, do that, do the other, and everything will just work. Okay? And there's some best practices around that, but really, it's great to be able to do that. That was one of the things I really loved about Docker when I started working with it.
Now, all of this and everything that we've just described is the layer that is Docker that sits on top of virtual machines and on top of the last 20 years of computers. But you haven't said why I need an orchestrator, because at this point, I'm still thinking Docker is amazing. That's really what I'll just use, right? I'll use Docker for everything. I'll Docker all the things. He might say, well, what happens when your Docker container stops? I'll say, hey, no problem. I'll just add -- restart always. And I'll just, while true, keep the Docker container running at all times. Problem solved.
Yeah, that should work.
No cloud. I got it handled. Docker is all I need, right?
Yeah, I think that would work.
Do you think that is going to fall down in any way?
No. Unless the server crashes.
Yeah, that is a problem I didn't think of. Well, thank you for telling me that.
What would you do then?
Yeah. If the hardware fails, if the disk fails, right? Just simply using Docker as a poor person's server to just keep things running, services in the background all the time, oversimplifies what needs to be done when one is actually orchestrating a large system.
So when we come to orchestration, we start to solve some of these problems. And you can actually do what's called a declarative deployment. That is, you write a YAML file, you say, look, these are the things I want, and then the orchestrator will say, okay, what's my current state? Where do I need to get to? And it will start to make changes to get you there, right? So we said we want one replica of Nginx. It will go and pull the image down on one of your nodes. It will start it up. If that node goes offline, it will say, what did I want? I wanted 1. I've got 0. And then it will bring it up on another node, right? You can do configuration through YAML, whereas your Docker run is kind of hacky, right? You've got these long command lines. You put them in shell scripts. A programmable API is fantastic. So Programmers love APIs. I really love APIs. I've used them in OpenFaas to be able to build this huge serverless system by using the Kubernetes API and saying, look, we need more instances of this microservice, right, this function. And the API will just go, OK, not 1, I want 5. And the cluster will do everything for me.
Every point here is important, but the one that is the most cloudy for me is that programmable API, that idea that the cloud has an API that I can call. Yeah. This little API here has a RESTful API, this little pile of Raspberry Pis where I can talk to it with whatever tool makes me happy. He made the comment that he's on a Mac and I'm on Windows. He can use curl, I can use wget, whatever. We can program this thing with PowerShell or scripts or Node or Python or whatever.
Right. The other thing that's really cool about using Kubernetes or an orchestrator is service discovery. Now, service discovery, with your Docker container, when you did Docker run, you would have got an IP address for it. But it would have been really hard to find that out, 10 dot whatever. I could send it to Scott on WhatsApp, right? This is a production IP address. However, with Kubernetes, whatever name you pick, you actually get a name on the network. So we would get nginx.local or something like that. And we can access our code through the service. Now, there you can do some really cool things with that, like you can do A/B testing. So you can have half of the clients go to Nginx 1, half go to Nginx 1.2, showing different sites. Okay, you can't do that with Docker Run. You have to add a lot of extra tooling in.
And that idea, and there's other talks that you can see that'll talk more about that, where you can have that service discovery in such a way that you could A/B test by saying in production, everything product catalog, authentication, authorization, shopping cart is all the same. But you know, every 5th call, I'd like to switch the shopping cart out. And all the code still accesses http://shopping cart. We can actually dynamically change that. That's just one simplistic example of what
I'm thinking we should do a demo after these last 2 points.
Let's do it, brother.
So high availability, I want to actually show you high availability. The elastic capacity is the sense that you can just keep adding computers. And Kubernetes is very extensible, right? So if you want to write your own kind of objects, you can. So high availability, that means that if one of the servers was to go down, we'd be all right. We'd recover eventually.
Right. So in the simplistic example I gave, I ran Fancy Pants at the command line. I unplugged my computer. Fancy Pants is offline.
Amateur filming.
So let's do a little bit of amateur filming. So here's what we're going to do. This is all the highest quality production values here at the NDC. So what we're going to do is this is all about me. We're not going to switch the camera around. We're going to switch this camera around. Thank you, sir. I'm going to fall off the stage. OK, so here is the cluster. Notice that the top one here does not have any lights. That's because that's the boss. That's Hansel Boss 1. Hansel workers 1 through 5 are there. So you see there that Hansel worker 1 is doing something. What's it doing?
Can I pull the cable out yet?
I don't want to pull the cable. You want to pull the cable out?
Yeah.
So it's running an app that's moving the lights. I'm going to pull the cable out?
Yeah.
OK, so I pulled that cable out. So right now, on the other side, it is no longer plugged in. And the cluster, though, when Alex set this up, he requested
one replica.
He requested one replica. He said, I want blinking lights on one of these things. Make sure it happens. Now, in production, you skip a heartbeat. It's not a big deal. You don't necessarily die. You maybe want to wait 4 or 5 minutes before you fully panic. But for the demo here, you turned the timeouts down a little bit, so we panic earlier.
Yeah. And actually, this is something you're not meant to do. Right? You're not meant to get into the guts of Kubernetes and start tweaking stuff. We actually...
Oh, there it is. So the top one, Hansel Worker 1, is still running, but it's off the network. And it hasn't shut down because it doesn't know what's going on. But Kubernetes noticed that that app is no longer running.
Yeah.
And said, wow, no one's paying attention. No one's taking care of blinking lights. And they moved it down to Hansel Worker 2 automatically. So now our blinking lights are distributed. Now I just plugged in it again.
Yeah, and in a few moments, what we'll see is now that the other node is back on, we said the orchestrator will have a desired state, and it's continually reconciling. So it will be like, well, there's 2 of those now that node's back on. We only said we want 1. So it will kill it. And we'll see that it's only one of those animations that's running. And that's what an orchestrator will do for you. It will save your bacon in production.
Now, is there anything in the code? Did you put anything in the way you wrote this flashing lights thing to say?
Well, yeah,
I mean,
I actually wrote a liveness check as well that checks every 5 seconds. But it was really when we'd said, look, if the node is offline for 30 seconds, then we need to reschedule the work.
Right.
Now, in production, you would not have your important application on one host. Like, it wouldn't make sense, because if it went down, you got your 30 seconds, or in production, 5-minute delay. Okay, so the other one's stopped now.
Yep.
What you'd do is have high availability. You'd say, right, I'll have 5 of them, right? Why not? If you lose 2 servers, you're still good. You're still serving Black Friday traffic. Yeah, and that's what you should do in production too.
Does that make sense? Cool.
Yeah, great.
Don't feel like you need to applaud. It's fine. We don't want your pity applause. We got to earn it.
Great. So
what happened?
What happened was, this is kind of what Kubernetes is doing behind the scenes, is we had a YAML file. Now, this is for Nginx, so a web server. It's not for our Blinked. And we said we want 3 replicas, so the deployment object starts to exist. Behind a deployment is a pod. And if you kill that pod, the deployment, again, it says, I want 1, I've got 0, it will recreate the pod. And then behind the pod is what you got from Docker run. So you can see how far removed this is from Docker run. So in development, and when you're learning this stuff, that's probably where you want to be. But when you start to move to production, Kubernetes and a scheduler is really where you need to be.
So if we go back just really briefly, if we go back there to here. So this image : that's Docker.
Yeah.
That's saying go and get it from here. So fancy pants : latest, Blinked, whatever.
Yeah, exactly.
And then you said the deployment is couple reserved from the container. There's the concept of deployment. Containers show up on pods. So if I go out to the command line and say cube control get deployment, you can see that I desire 1.
Yep.
I have 1, and it's up to date, and it's available, and it's an hour old. We started running this an hour ago.
So I mean, we could scale that to, we could always scale that to 5, and then you would see the cluster would just do its thing.
Is that hard? Like, I know that's not in the script or anything, but can you just make it all Blink? Because that might make them happy.
No pressure.
Because it's a tough crowd. The English are a tough crowd.
Scale, deploy, Blinked.
These little Blinked lights are actually sitting on top of the Raspberry Pi headers. They're only 5 pounds. We just ordered them and had them delivered really quickly. You just put them directly on the headers. They're individually addressable. You can animate and do colors and stuff like that. So not just for demos, but it can give you all kinds of information. So boom. Look.
How's that?
Yeah.
Okay, so that's why you need Kubernetes, okay? It's an orchestrator, and it actually has a bunch of building blocks. And there's a lot of them, but we want to try and give you some of the context. So there's master components, and there's node components. The master, as we said, is Hanselboss 1 at the top. And you can see it's not got any lights on it, because nothing runs on that other than these components listed down the side. Important things here are there's a dashboard, a web interface, and that's great if you like to look at things. I really prefer using the command line.
I am not as clever.
That's where Scott and I have different preferences.
Right. I like to just see that. I just
pretty colors.
I just stare at that and smile.
So back to the slides, and we have things in here like etcd or etcd. Once you start dealing with a distributed system and you're trying to unplug nodes and have everything still work, you need a way of having state highly available, right? And etcd will basically allow your state to be transferred across all of your nodes, and they'll kind of have a consensus about what is right, and they'll try their best to make that happen for you. We've got an API server. We talked about having APIs. There's a DNS I talked about earlier, and that's all master stuff. When you come to the node, you have your regular Docker, so your Docker run, but then Kubernetes has something called a kubelet that runs on there, and it talks to the daemon, right? So the kubelet is responsible for interacting with the cluster. And then you have additional stuff like the proxy that's to do with the DNS.
Here's a quick question. If I were to SSH on my own
Yeah.
into number 3.
Yeah.
Could I Docker run stuff?
You can Docker run, you can do Docker PS, and you'll see all of the Kubernetes stuff.
If I Docker ran Fancy Pants or something, would Kubernetes know that it existed, or would it not even know that that happened?
It wouldn't log it, it wouldn't track it.
Right.
Yeah.
So this is about going up another level, not hardware, not virtual machines, not even thinking about Docker. We're thinking about these deployments. It's a much higher level way of
We're
thinking.
talking about API objects, right? The way programmers like to think about systems. Docker is very much about your system, containers, running things ad hoc. Kubernetes, we're talking about declarative programming. Okay. So this is a zine or a zine by Julia Evans. I'd recommend you check out her material. This is just showing you roughly how the components fit together, and you see that etcd stores all the state, the API server talks to that, and everything else just plugs in.
It took me a while to get my head around what this was, but
Right.
etcd is kind of like Redis. It's just a distributed key value pair. It's a place to put all of this stuff.
Yep.
It's worth pointing out also that I have Hanselboss 1, but there's no Hanselboss 2. Well, in a true distributed system, if I were going to go and put my Raspberry Pi cluster into production, I would need a second Hanselboss in case the first one went down, and that would have basically a completely redundant system.
Yeah, and you probably have those in different regions.
Yeah.
But that's enough about the public cloud. Let's go back to the cluster. What can you run on here? Well, I loved just running an FTP server. Like, why not? You can run MPD, which is where you can have a music daemon running on it. And you can control it from your phone. There's a ton of stuff that's just quite fun. But it doesn't do much with clustering. So Python MPI is a programming interface that's really used very much in the traditional world, education, to split your program out and have it run across multiple machines. But it's hard to use. You've got to change your code. You've got to use Python, right? I like to do stuff like we're doing here, running a blog or a website on there, having all the components spread out. The kind of things you do not want to really do, or you can't do, is like you cannot accelerate your gaming. Like, you're not going to play GTA on this. You're really not. It's just not for that. Bitcoin mining, again, you may be able to control a Bitcoin miner with it, but just don't go there. You're just wasting your money. It will probably not even work. Obviously, right now, Windows binaries don't work so well, and we're not going to get to Skynet, although we could try.
So close.
Yeah, so close.
Now, people say that these might be underpowered. They might be a joke. These are silly little toy computers for $35, right? Well, Joe Armstrong, who worked on Erlang, said that the Cray was 160 MIPS. That is a 5-ton supercomputer. The word Cray means supercomputer. But it's worth pointing out that the Raspberry Pi is almost 20 times faster than that, one of them, and weighs about 40 grams. This is 6 of them all working together. So that's, what is that, 12,000, almost 14,000 MIPS. So many, many times more than a Cray.
Many times more.
And it only costs $300. And it turns out that Erlang itself was made for a VAX. So if your code is slow when you run it on this, it's probably your fault. It's kind of that's what I took out of Joe's tweet.
So let's go back to the talk. We talked about clusters, Kubernetes, and now OpenFaas. I actually have some stickers come up and get some at the end and some badges. Now, OpenFaas is a project that I've been building over the last 12 months in the community. It's an open source project, and it's about building serverless functions and running them on wherever you like, your own hardware or the cloud. But what is serverless? Well, I've given this talk a lot of times, and I think it's important to go back to basics. We used to build monolithic systems, 3 tiers. We had a database. They were very hard to test. They were really slow to deploy to production. We had like a 12-month cycle. They did far too many things. We then started to break them down into microservices that had constrained responsibilities. Okay, they did fewer things, they were easier to package, and actually that's where Docker and Kubernetes came in. We started to package these up and ship them. Well, as you can see, Kubernetes is kind of hard to work with. There's a lot of stuff there. So functions are the next step in that evolution, and we're breaking them down even more into small, discrete, reusable pieces of code we can write once and pretty much forget about. The system, as we go back to that picture where we talked about the Uber and the stick shift, this is the Uber of software. You write your program, CS, your handler JS, throw it across the wall, and the cluster will do everything for you.
Yep. To put it in another way, 20 years ago when I was working on shopping carts pre-Amazon.com and Black Friday started to happen, the shopping cart that we needed to scale was part of one giant monolithic app. And we thought we were clever by making a separate farm that was shopping cart dot our company. And the way that we scaled out the functionality of the shopping cart was a bunch of new hardware. The way that you do it in this world is you think about add item to cart, remove item to cart, all of those individual business problems. Which one is slow? And you'd scale up the function yourself, or maybe just let the system scale it for you, and we're going to see how that works.
Yeah, I'm going to show you a quick demo of a serverless function, and we're going to switch over to OpenFaas. A little bit more about the project. As I say, it's a community project, and really focus on developers first, so it's for you guys. There's a UI built in and a command line interface, a CLI. It has 9,000 GitHub stars. It's in 12 months. It won InfoWorld's Best Cloud Computing Software in the same category as Kubernetes and Docker itself. And it's got a thriving community full of developers. There's over 70 external contributors on the project, and it's the easiest way to run your own functions however you want them. Okay, so we'll go into a demo. And what I want to show you is our UI, or API gateway. Down the left-hand side of the screen, we have all the functions that are currently deployed, and we can actually deploy a new one from a store. And this is functions that are being submitted by the community. And one of my friends, Stefan, has done this SSL checker. Anybody use Let's Encrypt? Not enough. You should be using this. What it does is it gives you a HTTPS certificate for your website, but it runs out after
Can you check my
3
blog?
months.
Check Hanselman.com.
Hanselman.com. Are you on Let's Encrypt?
I don't know.
And when we hit invoke, so we're putting the information at the top, we get a progress bar, 200 status, how long it took,
Nope.
and we get a bit of information down here. So it's saying, Scott, you're good until
Next July.
next July. Okay, mine is going to run out in 3 months. Now, this is an example of a serverless function, and you could imagine how you could put that together with something like a Slack notifier, or maybe even an automatic renewal, so that you never have to worry about that running out again.
I want to make absolutely sure that people understand the leap that Alex made from Kubernetes into OpenFaas into serverless, because it might not be 100% clear. This UI is a Kubernetes application.
Yeah.
Right? I could go and take Fancy Pants or Hello World or whatever and deploy that as a Kubernetes application, and then I'd be responsible for scaling it and thinking about it and dealing with it. But what he's done is made a system where I could think of a function, literally a method, and call it do it in any language. And I'm another layer higher. I'm not even thinking about Kubernetes here, am I?
Right.
The closest thing, the only thing that I have, which is an insight into what's underneath, is where it says replicas right there. Otherwise, he's hidden Kubernetes from me.
That's correct. And we're actually running this on the cluster right in front of us here. And one of the functions we have is called node info. And when we invoke this, it actually gives you how many processes you've got. Maybe that's a bit small. It says 4, and it's giving us a host name. Now, if we run this again, because there's several replicas, I talked about this high availability concept. We should see 54D. It's actually just going to change every time we run this.
I don't know how many we have on there.
Yeah, so that just changed to 92J5K. And that's showing that each time we run it, it's actually going to another one of those nodes. It's automatically load balanced.
Now, speaking of load balancing and performance testing, is this valid perf testing? Because that seemed to go that's pretty fast.
Yeah.
What do you think? I invoked it 28 times.
I don't think that's enough for
You think?
scaling.
Maybe we can scale it a little bit better.
Yeah.
You want to switch over to your machine?
I think we're good.
No? What you doing?
So I'm just thinking about, do you want to talk a bit about the cluster and how we put it together, and then
let's talk a little bit about
on a high note. Maybe try some auto scaling.
Let's do that. Let's talk a little bit about the cluster really briefly, and then we'll. I'm going to just walk over to the cluster again, and then we can either deploy the .NET app or we can hit it with some real traffic, the Apache benchmark. I'm going to go over your head, sir. One of the interesting things that we're finding as we talk to people who are doing these clusters is the first impression is to go and buy a bunch of Raspberry Pis, stack them up, and then they put them on the Wi-Fi. Both myself and Alex have discovered through trial and error that while that does work, it can be really problematic. It doesn't make the cluster very portable. You want to go and make all these with static IP addresses or come up with a way for them to get reliable IP addresses. He prefers static IPs. I got a cool router. Everyone's like, I don't care about this talk, but that router is amazing. Notice that the router IP is 170.1. That's the inside, okay? Then this on top here is this lovely USB-powered 8-port hub, okay? So we plug the router into the hub with the white wire and then individually plugged in all over the side of the PIs. And then I've got static leases such that I've got .2, .3, .4 all the way down.
Yeah.
And that makes it very, very simple.
You do not want to use DHCP. Do not cut corners because you'll boot your cluster up and they're all trying to get back to that master .5. Yep. It's not .5 anymore, it's .11, and you have to run everything in again. So do things right. Do the static IP addresses.
Yep. And we found that when carrying this around to conferences and stuff, what's nice about this particular thing, it's called an amplify, is it actually shows you the WAN IP. So all we had to do was plug this into the hotel Wi-Fi, or the conference center Wi-Fi, wired rather, and the point here, none of the internal IP addresses change. Does that make sense? Yep. All this needed was to get to the outside. Now, that's another interesting point. We can get to the outside, which means I can deploy my Docker containers to a registry and then pull them back down.
Should we try that?
That's
for .NET?
Yeah, let's do that maybe.
.NET app.
So let me go back over here.
Anyone want to see .NET Core?
Let's
no? Doesn't look like it.
They don't care. They're just trying to figure out what Kubernetes is.
Yeah.
So I'm out here at the command line.
You're going to go a bit bigger.
You don't think make it a little bigger? And then tomorrow I'm giving a talk at 3 o'clock. And at that talk, you can discover what that green arrow is right there. That's my blood sugar in real time, because I'm diabetic and I don't want to die in the middle of the talk. It's funny because it's true.
Okay.
So from in here, I've got .NET Ping YAML.
This is not a Kubernetes YAML. This is an OpenFaas YAML.
Yeah. Right? So this OpenFaas YAML is saying, here's where the handler is. Here's the Docker image. Hanselman /.NET Ping. That's why people call it that. And it's up at Docker, right?
Yep.
But it could have been in an internal registry.
Right.
That is one of the flaws in the way I built this. One of the suggestions that Alex had made was, why don't you run a container registry on the Kubernetes cloud itself?
Yeah.
So it could run its own app. I would then push to itself, and then it would talk back to itself, and then inception in the world.
I told you 2 years ago how to build all of Docker from source.
Yeah.
Not even Kubernetes, Docker itself. You actually still have to build the registry from source. And I did that a couple of weeks ago. And people are asking me things like that. And I'm like, well, it's not as easy as it sounds. There are still a few bits where it's going to work against you. You're going to run MongoDB. You're probably not going to find it. And you might have to go and find the Docker file and rewrite it for ARM.
Mm-hmm.
Right.
So I'm going to change this version to .6.
Okay, go for it.
And then where's my my code? I think is in function handler. Mm-hmm. I'm using Notepad, which is one of the great IDEs. Is it England or Britain? What are the rules? What am I supposed to say?
I can go for either.
UK?
Maybe London is safer. Yeah.
London's probably safer.
Yeah.
Okay. So notice that I'm saying system.environment.machine name.
Right.
Because it might be on a different different machines. And I want to point out, before I do anything, if I go over here to the...
So we only wrote a handler there. We didn't write a whole application. We didn't have to think about ASP.NET. We had no NuGet packages.
I just said handle.
For you. Yeah.
Could I have named it anything, or does it have to be called handle?
This one, handle, yeah.
Okay. So that's my do it. And it's also worth pointing out that I'm not saying, hey, HTTP...
.write, whatever.
Console.write line.
Console.write.
Which makes it easy to test locally, and then I can go out to the cloud.
And you can work with binary data as well.
So from within here, then, I could build this, and then make the Docker, build the thing locally, build the Docker container, push the container, but I've got a CLI. As he said, OpenFaas has this great...
Fast CLI.
Fast CLI.
And you can even do things like... Can we do this from where we are?
I don't know. Break the whole machine at this point. I don't know what's happening.
.net.yaml.
.yaml.
There we go. So we can actually even use it to list the functions that are in the cluster right now without touching the Kubernetes API. Yeah. If we do dash-verbose, we see we've got .NET ping 0.5. We're about to do...
So there's one replica of 0.5, and we're going to go and do more. And I went and made a batch file to do that.
Yeah.
It's using fast CLI, which will ultimately use Docker, which will ultimately use Kubernetes stuff, et cetera, et cetera.
Yeah.
But you've hidden all that. Is this okay, this -- replace at the bottom there on deploy?
I'm not sure if that's right, but however, let's just do this.
You want to do it one at a time?
How do I do this on Windows?
You select it and then you hit enter. There you go. And then everything goes to hell and it doesn't.
Is that okay, that?
Oh, that's bad. You've ruined everything. I don't know what's happening.
Is this because you're not in as an administrator?
It's definitely not that.
Is Docker?
It only likes me to touch it.
Okay.
So what we're going to do is make sure. I think we build it higher up one.
It is in this directory.
What are you doing, man? I have no idea what's happening.
Trying to see if I can work around.
No, I want to actually. I want to.
The technical problem we were having there.
Oh, I was going to do something.
We're now pushing up the other image, and because we didn't actually manage to build it,
But you didn't give me a chance to panic on stage, though. May I try?
Yeah.
So when I don't know what I'm doing, I go to my giant Kubernetes open notes page here, and then I just look frantically around for anything that might have possibly told me that it was the right thing. And I got all kinds of stuff. Your name is in here a lot, by the way. Lots of links to Alex's blog and different things like that.
It was the right thing.
Yeah.
I wonder if you need to be an administrator or do it through a normal command prompt.
Oh, I don't know. Let's find out. A normal command prompt, you mean like DOS?
Yeah.
Yeah. Let's feel bad about that if that's the case. And let's make the font bigger. I know we have only seconds of time. Actually, we have lots more than seconds. Don't worry, we'll be fine. But I don't like to just yada, yada, yada over stuff. I want to see it actually fail horribly. There we go. Yeah. So here, what we're doing is something really interesting. You can't, this is ARM, right? So we're on a Windows. Am I having a stroke? I have like 8 minutes, dude.
Yeah.
Hey, light person, bring it back down. No? Did he leave? All right, well, even though the lights are on, I know I have like 7 minutes 55.
Yes.
So I reject you, light guy.
I want to show you.
Yeah. So what I want to point out is that we can't do the build on ARM because ARM doesn't have a .NET SDK. It would be too slow. Remember how he mentioned that he was building Docker itself on Raspberry Pi? It's a huge hassle. .NET Core has a really interesting thing where you can go and say .NET publish -r and put in a runtime ID. So I can say .NET publish -r Linux ARM. So I'm building and emitting the stuff that I need for ARM on Windows.
Yeah.
But what we're doing is we're doing the build in one Docker file. So for a moment in time, the Docker lives there. We pull it out, put it in another Docker file, which is our smaller runtime version of the thing, right? One is x86. That's where we build. Then we copy out the ARM results and put them in an ARM-specific one that I can't run locally.
Right.
And we're pushing that one to the cloud.
If you look at where I've got the cursor right now, right up top, this is .NET 2 SDK. That is a Windows Docker image. A Linux Docker image. It will not work on the Pi. That's why we're using that here. Then on the laptop, we're saying publish, and at the end of that line, Linux ARM. So it's going to build a binary for the ARM processor, but on our regular PC. Right. So for one, it's actually quicker, but two, like Scott said, you just can't do it on ARM yet. The .NET Core team just haven't quite got there yet.
To be clear, though, that .NET publish is happening not on the PC, but inside the Docker container that happens to be running on the PC.
Exactly. And then the magic piece here is something called multi-stage builds. You can read about this on my blog and the Docker docs. Is we're then saying, now use the ARM runtime image of .NET and just copy the binary across. That's it. And then we publish that to the cloud.
If you've ever done Docker before, you're familiar with the from syntax. Here you've got from twice. That second from is that second stage, that multi-stage.
Yeah, that's right.
And then a lot of people were giving me a hard time online recently about how I was staring at something for hours and I didn't see the /. That was the / that wasted an entire day in the lower left-hand corner right there. That F watchdog, that function watchdog, is just going to make sure that .NET stays up and
that's right.
things are going.
Yeah.
So if we go back over here and just remind ourselves of what we did, we went and we built this.
Yep.
See the multiple stages,
Yep.
copying that information out.
Did we deploy?
And then fast push,
Yep.
fast deploy.
Okay.
And it said accepted. Unfortunately, we were talking
We should see that new version.
when it happened, which is horrible. What are we doing? I'm going to go back over to the dashboard that you despise, and I'm going to click on it. And look,
Yeah, 0.6.
0.6. So now, remember that I'm choosing to look at Kubernetes. Don't have to.
Yeah.
The right thing for me to do is to go back over to the UI for OpenFaas and look at .NET Ping,
Yeah,
version
0.6.
hit invoke.
Hello, London.
I love it.
There we go.
Yeah. So why don't we end on auto scale?
I think we should scale now.
All right.
Can you do me a favor and show Grafana?
Oh, yeah. So Grafana is this lovely little, this amazing dashboard that I'm running locally. Now, this is a little bit of inception here. I said Docker run, blah, 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 Grafana. It's like graph, but with an F. And I'm running it locally, and then I've loaded in data sources. Grafana is going to aggregate from JSON APIs that are inside of the Kubernetes cluster that you can then provide arbitrary values to. So unzoom.
Yeah.
There you go. How's that? So what Alex and OpenFaas has done is included a JSON file that is in the Grafana format that says, here's some of the really interesting perf counter stuff you might want. So Grafana is a Docker-based perfmon for stuff like this. So what we've got is the replica scaling.
I've just run in a few requests from my laptop into the cluster.
Ah, look. So you can see the requests are going up.
I'm generating some hashes using a hashing function. I'm just pressing up and enter. It's kind of slow.
And notice right here that there's the .NET one that I just put there. There's node info, and then there's this SHA-SUM that he's calling on.
So all of these metrics are built in for you. You don't have to do anything. If you wanted to get metrics in your .NET Core app, you'd have to do that yourself. With OpenFaas, it's all built in for you.
Yeah. So what we've put here is Apache benchmark, and we put it into Ubuntu. So what we're going to do is we're going to call SHA-SUM a lot, and we're going to just beat on that machine with the benchmarking application. If we go back over here, can we change that to refresh a little more often?
No,
that's 5 seconds
max.
enough?
That's max. But what we can see, and this is the important one, total requests is going up pretty quick.
900, 1,200.
There's a bit of a skip there, because with a distributed system, you don't want to fill your cluster with traffic that's just about instrumentation, right? You want that to be your application.
Look what just happened on replica scaling. Maybe you can hover over that. He's hit it so hard, and this is where things really get powerful. He's hit SHA-SUM so hard that it said, I don't feel like I'm effectively serving this traffic. We only had one replica, but we've got 5 Raspberry Pis. It went and made 5 replicas of SHA-SUM automatically.
That's
we made a
keep
function
going up,
called
Scott.
do it. Now, SHA-SUM, what do you think that language is written? What do you think the language is? Is it .NET or Node or Python or Go?
It's a built-in bash function.
He's calling bash, and now he's put it in the cloud in serverless. Now, ordinarily, serverless means give us a function, put it in the cloud, hand us your credit card, and then move the slider bar. And the slider bar goes as far as your credit card will allow it to. But the exciting part about owning your own little cluster is that you don't have to outlay anything. We can go and do all kinds of stuff.
So
look at that, 7,000 requests.
we got up to 10 replicas, and now I've stopped that load test. It's actually going to go back to 1 again, because you shouldn't pay for what you're not using, right?
Can you talk about how we have 10 replicas, but we have 5
Yes,
physical
so
devices?
the 10 replicas will be spread however Kubernetes sees fit across those devices.
Yeah. So you can have
device.
Yeah, and there's multiprocessor, and you can have as lots.
Yeah, so there's 4 cores in the RPI, right? So we could probably run 4 processes quite happily.
Yeah. So we've got 20 different processors running.
We've gone back down now.
And now it looks like it
Now
saw
it's
that there's not much
We're
traffic.
now at 0 or 1 again.
Went back to desired state, which would be 1.
Yeah.
All right. That's pretty hot too, isn't it?
There's the Bitscope cluster.
Yeah. So what's next? How far do we take this? Well, we talked a little bit about networking, about how to build this kind of stuff. I talked about the challenges of networking. How far could you go?
So the University of New Mexico is building out this cluster. I believe it was either 300 or 3,000 nodes they're trying to get to. They're not going to run their actual scientific experiments on it, but they are using it as a cheaper way of figuring out how to build systems. This is from Bitscope, and on the left-hand side, you've got the 30 node that they sent me to play with. And this is just, I mean, just look at the difference between what we've put together, wires everywhere. It's industrial-grade IoT.
So please send us free Raspberry Pis.
Yeah.
So we are way out of time at this point, but we hope that you've learned how and why you should build your Raspberry Pi cluster. We should probably throw this into the audience randomly. I hope that you can learn some Kubernetes, try some .NET Core, and it's great that you can do it on ARM. And above all, try out OpenFaas.
Who wants a large T-shirt? Okay.